Welcome to Maths Guru Educational Services. If you are studying with us on Maths Guru channel for the first time, kindly subscribe so you will be informed anytime we upload a new video on this platform. This channel is dedicated to the students of the National Open University of Nigeria, offering educational administration and planning. In this section, we are going to discuss the table, and we title it Understanding the Statistical Table. Understanding the Statistical Table. This will help us to understand the 5th and 6th units of the course material. So we're going to do this in line with the past question taken from 2020 past question. So we have it here displayed, and we're going to learn how to resolve this question as we treat the concept of understanding the statistical table. First, we have the frequency distribution. A frequency distribution is a tabular presentation of data showing how often each score or group of scores has occurred. Like what we have here is a grouped distribution. A grouped distribution, and we have the frequency of each of these classes. Waiting below, we have the score 15 to 19 with a frequency of 4, 20 to 24 with a frequency of 16, 25 to 29, 12, 30 to 34, 24, 35 to 39, 14, 40 to 44, 12, 45 to 49, 8, 50 to 54, 6, 55 to 59, 2, and 60 to 64, 2 also. And we are required to determine the class size of the distribution, the upper limits of the class, the lower limit, the class mark of the class, the class boundary of the class, the relative frequency of the class, and the cumulative frequency of the distribution. All right, the B section is talking about the probability. Okay, we're going to talk about all this. All right. In statistics, a class is a grouping of values by which data is bound for computation of a frequency distribution. We can see that all these scores, like this grouping here, 15 to 19 is a class, 20 to 24 is another class, 25 to 29 is another class, 30 to 34 is another class, 35 to 39 is another class, 40 to 44 is another class, 45 to 49 a class, 50 to 54 a class, 55 to 59 is a class, 60 to 64 is the last class given here. So that is what we mean by the term class. Now we have the class limits. The class limits. There are 2 for each class. The class limits are 2 for each class. The lower class limits of a class is the smallest data value that can go into the class, while the upper class limit of a class is the largest data value that can go into the class. So if we talk of this first class now, the highest that can come into this class is 19 and the lowest is 15. So the class limits the lower class limit of this very class is 15. The lower class limit of this very class is 35, and the upper class limit is 39, so on. Like the last class we have here, the lower class limit is 60, while the upper class limit is 64. That is how to determine the upper class and lower class limits of any particular class given. All right, the class mark. It is the arithmetic mean of the class limits. Arithmetic mean of the class limit. We discussed arithmetic mean in our previous class. So if we are to determine the class mark of each of these classes given to us, for the first class we have 15 plus 19, and then we divide it by 2. 15 plus 19 divided by 2, we have will be equal to 17. For this, the class mark will be 20 plus 24, and then we divide it by 2, and this will give 22. For this, we have 25 plus 29, then we divide it by 2. 25 plus 29, we're going to have 54, and when we divide it by 2, we will have 27, right? Then for this class, we're going to have 30 plus 34, which will be 64, and when we divide it by 2, we are going to have 32. For this, we're going to have 35 plus 39, 35 plus 39, this will give us 74, and when we divide it by 2, we are going to have 37. For this, we're going to have 40 plus 44, this will be equal to 84, and when we divide it by 2, we're going to have 42. Here we have 45 plus 49. 45 plus 49, this will give 94, and when we divide 94 by 2, we are going to have 47. 47. All right, we have 50 plus 54, which will give 104, and when we divide it by 2, we are going to have 52. All right, 55 plus 59. 55 plus 59 will give 114, and when we divide it by 2, we are going to have 57. Then we have 60 plus 64 here. This will give 124, and when we divide it by 2, we're going to have 62. So this is how we determine the class mark whenever we are given a grouped distribution table like this. All right. Okay, let's quickly resolve the question given to us here. We are to... Okay, is there anyone? Class mark, okay. Question number 4. We have the class mark of the class 45 to 49. 45 to 49. And we have 45 to 49 here. The class mark is simply 47. The class mark is simply 47. So that is how to do the class mark anytime, any day you are given a question like this. Now, the class boundary. The class boundary is there are halfway points that separate the classes. And what we mean by this is very simple. Sorry, we have to wipe off this frequency and then put some class boundary here. So the class boundaries, remember we have the lower class boundary and the upper class boundaries. The lower class boundary and the upper class boundary. Like the question number 5 here is to find the lower class boundary of this very class. In order to find the class boundary, what we do is take half from the lower class limits, then add the half to the upper class limits. So the lower class limit is 15 here. So if we take half from 15, we are going to have 14.5. 14.5. Then the upper class limit, we're going to add half. If we add half, it will become 19.5. For the second class, take half from the lower class limit, we're going to have 19.5. That is 0.5. Then when we add that to the upper class limit, we're going to have 24.5. So the next class, we're going to have 24.5, and then add it up to the upper class limit, we're going to have 29.5. So we have here 29.5, then to 34.5. We have 34.5 to 39.5. We have 39.5 to 44.5. We have 44.5 to 49.5. 49.5 to 54.5. 54.5 to 59.5. Then we have 59.5 to 64.5. What we are doing simply is to take half from the lower class limits, then add the half to the upper class limits. I think that is a very simple way to explain this aspect of a table. So for question number 5 now, that is Roman numeral 5, the lower class boundary of the class 55 to 59. We have to locate that. 55 to 59 is here. So the lower class boundary is simply 54.5. That solves the question. I believe this is understood. If you do not get the explanation well, kindly take back your video so you will get the explanation correctly before you move to the next one. Then the class width. The class width. The class width is simply the difference between the higher class boundary and the lower class boundary. That is the upper class boundary and the lower class boundary. That is simply the class width or the class size. So let's quickly do that here. Class width. To determine the class width of this first class, all we need to do is to subtract the upper class boundary, the lower class boundary from the upper class boundary. From what we treated earlier, you can see that here. The upper class boundary of this class is 19.5. 19.5 minus the lower class boundary of this will be 14.5. And when you do this, you're going to have it's equal to 5. For this kind of distribution, the class width will be the same for every class you choose to. For instance, if we should take 50 to 54 now, the upper class boundary will be 54.5. We subtract the lower class boundary, which is 49.5, and this will still give 5. So for any of these classes, the class width remains. So to solve the first question, the class size of the distribution is simply 5. The class size is simply 5. Take any of the class and subtract the lower class boundary from the upper class boundary. You will have the value 5 as the class width. Then the next concept is the relative frequency. The relative frequency. Here we have the frequency, the scores aligned to their frequencies here. For us to determine the relative frequency, we simply take the ratio of the frequency of that particular class to the total number of scores, that is the total frequency, the sum of the frequency we have here. We just have to calculate summation F. And when we do that, we're going to have 4 plus 16, that will give 20. 20 plus 12, we're going to have 32. 32 plus 24, we're going to have that is 36, 15, 56, right? Yes, 56. Then 56 plus 14, we're going to have 70. 70 plus 12, we're going to have 82. 82 plus 8 now is, we're going to have 90, right? 90 plus 6. Plus 6, that will be 96. 96 plus 2, we give 98. And 98 plus 2, we're going to have 100. So it means the total frequency of this distribution is 100. To determine the frequency, the relative frequency of each of these classes, what we need to do is to divide the frequency of that particular class with the total frequency, that is the total number of data in this distribution. So we simply say 4 over 100 for this, and this will give 0.04, right? For this, we're going to have 16 over 100, which should be equal to 0.16, right? Then we have 12 over 100. This will be equal to 0.12. For this, we have 24 over 100 to be 0.24. For this, we're going to have 14 over 100, which is 0.14. For this, we're going to have 12 over 100, 0.12. 8 over 100 equal to 0.08. And then we have 6 over 100 to be equal to 0.06. 2 over 100, 0.02. And then 2 over 100, the same thing, 0.02. So this is how to determine the relative frequency of any particular class. Now, back to the question given to us. The relative frequency of the class 20 to 24 to 2 decimal places. We have 20 to 24 to 2 decimal places will be 0.16. We picked everything. And that will give us the relative frequency of that particular class 20 to 24. All right. The next thing is the cumulative frequency. The cumulative frequency. We discussed the cumulative frequency before. Here we are simply going to resolve this. To determine the cumulative frequency of this, all we need to do is sum this to this. There is no number, no class before this. The frequency is simply 0. That is 0 plus this 4, we give 4. 4 plus 16, we give 20. We take 20 plus 12 now, we give 32. So this is what we are doing. We add the first frequency we have here to the next one, which gives 20, and then add 20 to the next one, which gives 32. We are going to add 32 to this one now to have this frequency, which will be 56. So 56. Now we're going to add 56 to this, and this will give that is 0.70. So give 70. 70 to 12, we're going to have 82. 82, we add it to the next frequency, which will give 90. Right? Then 90 plus this plus 6, we're going to have 96. We add it to the next one. Oh, I think this should be 2. It is on the table here. It's supposed to be 2. All right. So this will be equal to 98. And when we add this to the last one, we're going to have 100. So the last row on the cumulative frequency column must tally with the total number of frequency we have, the total number of data in this distribution. All right. we have come to the end of this discussion. If there is any question you need to ask, you can comment below this video and we'll respond to them, or you can send us a message on 09035173164 and we'll respond as quickly as possible. Thank you for watching. Please don't forget to subscribe, share our video, and like the video as well.